What if the night sky is not just beautiful, but impossibly distant? What if every star you see is not shining in the present moment, but sending you a message from years, centuries, even thousands of years ago? Tonight on Velorin's Sleepy Space Mysteries, we gently explore the true meaning of a light year, not as a number, but as a feeling, a scale, a realization that quietly reshapes how you see the universe. Light travels at about 300,000 kilometers per second. In 1 year, it crosses roughly 9.46 trillion kilometers. That number alone is enough to overwhelm the mind. But what does it actually mean for us here on Earth? Why did astronomers abandon kilometers and adopt light years? And what happens when we truly understand that Proxima Centauri, our nearest stellar neighbor, is 4.24 light years away? Stay with me, because by the end of this journey, you may never look at the night sky the same way again. If quiet scientific explorations help you relax, subscribe, like, turn on the notification bell, and consider joining our membership for deeper cosmic journeys. Before we continue, tell me in the comments where you're listening from. Let's see how far this signal travels across Earth. Now let's begin gently. Not with stars, not with galaxies, but with something simple. Kilometer. You know what a kilometer feels like? It is roughly the distance you might walk in 10 or 12 minutes at a comfortable pace. If someone tells you the grocery store is 1 kilometer away, you can picture the walk. You can imagine the corners, the sounds of traffic, the rhythm of your steps. 5 kilometers feels longer, but still manageable. 200 kilometers feels like a road trip. 4,000 kilometers might carry you across a continent. These are distances your mind can hold. The circumference of Earth at the equator is about 40,000 kilometers. That number sounds large, but it is still human. Planes circle the globe in less than 2 days. Ships have done it for centuries. Even 40,000 kilometers fits inside our imagination because we live on this planet. We have touched its surface. We know its scale. Now let's step outward. The distance from Earth to the Moon is about 384,000 kilometers. Pause there. 384,000. If you tried to drive that distance at highway speed, say 100 kilometers per hour, without stopping, it would take you nearly 160 days. Almost half a year of non-stop driving. And that is just to our nearest celestial neighbor, the bright disk you can see with your own eyes. Light itself takes about 1.3 seconds to travel from the Moon to Earth. That is our first quiet shift in perspective. Even the fastest thing in the universe does not move instantly. It needs time. 1.3 seconds is short, barely a breath, but it is not zero. Now let's widen the scale again. The distance from Earth to the Sun is about 150 million kilometers. 150 million. Your mind hears the number, but it cannot feel it. Even our fastest spacecraft would need months to cross that gulf. Light, moving at about 300,000 kilometers per second, takes about 8 minutes to travel from the Sun to Earth. 8 light minutes. When you see sunlight on your skin, you are feeling energy that began its journey 8 minutes ago. 300,000 kilometers per second. Let that settle in. In a single second, light could circle Earth about 7.5 times. In the time it takes you to blink, light could travel from Earth to the Moon and most of the way back. And yet, even at that unimaginable speed, it still needs 8 minutes to reach us from the Sun. This is why kilometers begin to fail us. If we tried to describe the distance to the nearest star beyond the Sun in kilometers, the number would become absurd. Proxima Centauri is about 4.24 light-years away. In kilometers, that is roughly 40 trillion kilometers. 40 trillion. A trillion is 1,000 billion. If you counted one number every second without sleeping, it would take you more than 31,000 years just to reach 1 trillion. And we are talking about 40 of those. This is where the human brain quietly gives up. Our cognitive limits evolved for survival on the savannah, not for measuring the gulf between stars. We are comfortable with tens, hundreds, even thousands. Millions stretch us. Billions become abstract. Trillions dissolve into fog. So astronomers changed the language. They did not invent a new distance, they simply expressed it differently. A light year is the distance light travels in 1 year. At 300,000 kilometers per second, multiplied by 60 seconds per minute, 60 minutes per hour, 24 hours per day, 365 days per year, light travels about 9.46 trillion kilometers in a single year. That is 1 light year. 9.46 trillion kilometers. But saying 1 light year feels calmer, more contained. It turns an impossible string of digits into something we can compare. Now imagine this. Voyager 1, the most distant spacecraft humanity has ever launched, is about 24 light hours away. That means its signals take roughly 1 full day to reach us. When engineers send a command, they wait 24 hours for it to arrive. When Voyager replies, they wait another 24 hours. A simple exchange takes 2 days. And yet, 24 light hours is still less than 1 light day. Less than 1/365th of a light year. Voyager has been traveling since 1977. Nearly half a century. Moving at about 17 kilometers per second. And after all that time, it has not even traveled 1 full light day from Earth. That is how vast a light year truly is. Now return to Proxima Centauri, for 0.24 light years away. If you could travel at the speed of light, which you cannot, it would still take 4 years and a few months to arrive. With our current spacecraft speeds, the journey would take thousands of years. Entire civilizations would rise and fall while a probe drifted between those stars. And yet, in cosmic terms, for light years is close. Inside our galaxy, distances are measured in tens of thousands of light years. The Milky Way itself is about 100,000 light years across. Our Sun sits roughly 26,000 light years from the galactic center. Light leaving that central region began its journey toward us when humans were still living as hunter-gatherers. This is the quiet rhythm of scaling. 1 kilometer. A walk. 384,000 kilometers. The Moon. 150 million kilometers. The Sun. 8 light minutes. 24 light hours. Voyager. 1 light year. 9.46 trillion kilometers. For 0.24 light years. The nearest star. And suddenly, Earth feels very small. Not fragile. Not insignificant. just small like an island in an enormous dark ocean. When astronomers use light years, they are not trying to make things dramatic. They are simply choosing the only unit that does not break under the weight of reality. Kilometers shatter at these scales. Light years remain steady. They remind us that distance and time are woven together. When you look outward, you are also looking backward. Your mind may struggle with trillion-scale numbers, and that is okay. The purpose is not to calculate every digit. The purpose is to feel the gradient, the steady climb from the familiar to the unimaginable, from your street to the moon, from the moon to the sun, from the sun to the nearest star, from one star to a galaxy of hundreds of billions more. And through it all, light travels. 300,000 kilometers every second. Tireless, constant, crossing darkness that our species may never physically cross. If you are still here, still drifting through these expanding scales of distance with me, type 1 in the comments. Let us continue this quiet scaling, moving carefully outward, step by step, so the mind can adjust rather than recoil. We have reached 1 light year, about 9.46 trillion kilometers. Instead of staring at that number, let's soften it. Imagine light leaving Earth at this very moment. It moves at 300,000 kilometers every second. In 1 second, it circles our planet more than 7 times. In 1 minute, it travels 18 million kilometers. In 1 hour, it crosses over 1 billion kilometers. In 1 day, that light has traveled about 26 billion kilometers. After 1 full year of uninterrupted motion, never slowing, never resting, it has crossed 9.46 trillion kilometers. That path is a single light year. Now imagine shrinking that enormous journey back down to something human. If 1 kilometer were the length of a single step, then a light year would be 9.46 trillion steps. Even walking 1 step per second, you would need nearly 300,000 years to finish. That span is roughly the age of our species. Modern humans have existed for about that long. So in the time it took humanity to evolve, spread across continents, invent language, art, agriculture, cities, and technology, light could travel only about 300,000 light years. That sounds enormous, but even that is only 3 times the width of our galaxy. Perspective reshapes everything. Let's zoom back inward for a moment to keep our footing. The Earth-Moon distance, 384,000 kilometers, feels large until you compare it with Earth-Sun distance, 150 million kilometers. The Sun is almost 400 times farther away than the Moon. Yet even that distance shrinks dramatically against a light year. 1 light year is more than 63,000 times farther than the Sun. If the distance from Earth to the Sun were the thickness of a sheet of paper, then a light year would stretch for dozens of meters. That is the scale shift we are trying to feel. Our minds prefer smooth continuity, but cosmic distance grows exponentially. This is where cognitive limits quietly appear. We evolved to estimate the distance to a tree, a river, a herd. We did not evolve to comprehend trillions. 1 million seconds is about 11 days. 1 billion seconds is about 32 years. 1 trillion seconds is over 31,000 years. So when we say 1 light year is 9.46 trillion kilometers, we are not just using a large number. We are invoking a magnitude that stretches beyond normal intuition. Now return to Voyager 1. It is about 24 light hours away. Light leaving Voyager takes roughly 1 day to reach Earth. That means Voyager is about 1 light day from us. 1 light day is about 26 billion kilometers. Voyager has traveled for nearly 50 years at around 17 kilometers per second, and yet it has only just crossed that single light day boundary. 1 light day is only 1/365th of a light year. That means Voyager has covered less than 1% of the distance to the nearest star. If Proxima Centauri is 4.24 light years away, that equals roughly 1,500 light days. Voyager has completed only one. Even if it continued for tens of thousands of years, it would still not reach Proxima. And Proxima itself is just our nearest neighbor. Within a sphere of 10 light years around us, there are only a few dozen star systems. That sounds sparse because it is sparse. Space is not crowded. It is mostly emptiness punctuated by islands of light separated by years of travel at the fastest speed possible in nature. Imagine shrinking the sun down to the size of a small coin. On that scale, Earth would be a tiny grain of sand orbiting a few meters away. Proxima Centauri, still on that same scale, would be thousands of kilometers distant. Not meters, not kilometers, thousands of kilometers. That is how empty interstellar space truly is. And this emptiness is why astronomers surrendered kilometers in favor of light years. Kilometers are too fine-grained, like measuring the width of an ocean in millimeters. Light years smooth the scale. They align with the ultimate speed limit, 300,000 kilometers per second. When you say 4 light years, you are also saying 4 years of light travel. Distance and time fuse into one concept. That fusion changes how we perceive the night sky. Every star you see is separated from you not just by space, but by years. Even the nearest star's light left before a child born today could speak. This is the quiet truth behind scaling the impossible. We are not just mapping distances, we are mapping delays. Every additional light year is another year of separation. The Sun feels immediate at 8 light minutes. Proxima feels remote at 4 light years. The center of our galaxy feels ancient at 26,000 light years. Each step outward adds layers of temporal distance. And yet, we remain connected by photons crossing the dark without pause. If you are still listening, still allowing your imagination to stretch gently beyond its usual limits, continue with me. We are not rushing. We are simply learning how to breathe at larger scales. Now let us stretch even farther, but slowly, so the scale unfolds rather than overwhelms. We have stepped beyond the Sun, beyond Voyager, beyond the nearest star, and we are beginning to sense that space is not simply big. It is structured around distances so vast that they redefine what far means. For 0.24 light years to Proxima Centauri may already feel unreachable, yet within our galaxy that distance is almost nothing. The Milky Way is about 100,000 light years across. If you imagine reducing the distance to Proxima Centauri to the width of your hand, then the width of the entire galaxy would span thousands of kilometers. That is the next cognitive jump. Our sun sits about 26,000 light-years from the galactic center. Light leaving that central region began traveling toward Earth 26,000 years ago, long before agriculture, long before cities, long before written language. All of recorded human civilization has unfolded while that light was still en route. This is the subtle power of scaling. It compresses human history into a fraction of a galactic blink. Now consider what 100,000 light-years truly represents. Light, moving at 300,000 kilometers per second without ever slowing, would require 100,000 years to cross from one side of the Milky Way to the other. That means if you could ride alongside a beam of light, which you cannot but imagine, you would need to travel for 100 millennia just to reach the opposite spiral arm. Modern humans have existed for about 300,000 years. So in the entire lifetime of our species, light could have crossed our galaxy only 3 times. That realization gently resets our sense of proportion. And yet, the Milky Way is only one galaxy. There are hundreds of billions of stars within it, perhaps 200 billion on average, each separated from its neighbors by light years. Between those stars lie vast regions of near emptiness, thin gas, drifting dust. Even at the speed of light, crossing from one side of a typical stellar neighborhood to another requires years. Now expand the scale again. The nearest large galaxy to us, Andromeda, is about 2.5 million light-years away. 2.5 million. Light leaving Andromeda when early humans were first shaping stone tools is only now arriving at Earth. If you tried to express that distance in kilometers, the number would contain so many zeros it would feel meaningless. This is precisely why light years remain the only sensible unit. They anchor distance to something constant, time multiplied by the cosmic speed limit. But here is something even more humbling. The observable universe, the region from which light has had time to reach us since the beginning of cosmic expansion, stretches about 46 billion light-years in every direction. That means the observable universe is about 93 billion light-years across. Not because the universe is that old in simple years, but because space itself has been expanding while light traveled. Even that statement stretches the mind. We are not simply measuring static distances. We are measuring distances within a fabric that stretches. When you look outward, you are looking through layers of time and expansion simultaneously. At these scales, trillions fade into insignificance. A light year felt impossible. Now we are speaking of billions of light years. The difference between 1 billion and 1 trillion already shattered intuition, but here we are stacking billions of light years like stepping stones across cosmic time. This is the boundary where cognition becomes symbolic. We cannot feel billions. We can only compare them. If 1 light year were the thickness of a sheet of paper, then 1 billion light years would stack papers high enough to stretch into space. That comparison is imperfect, but it hints at magnitude. And yet, despite these distances, light remains the thread connecting everything. Photons born in distant galaxies travel for millions or billions of years and eventually end their journey in a telescope mirror, or even in your eye. That means when you look at a faint galaxy through a telescope, you are intercepting light that began its journey before Earth formed. before the sun existed, before our planet cooled. That is the quiet poetry of scaling the impossible. Distance becomes a time archive. The farther away something is, the older the light you receive. But let us return gently to something closer, to avoid drifting too far too quickly. Remember that Voyager 1 is only 24 light hours away. That is less than 1% of 1% of the distance to Proxima Centauri. Proxima itself is only 4 light years away, while the galaxy spans 100,000. And beyond our galaxy are trillions more stars in other galaxies, separated by millions of light years. The ladder of scale never truly ends. Yet every rung is built from the same constant, 300,000 kilometers per second. That speed governs the structure of causality itself. It defines how quickly information can travel. It defines how quickly connection can occur. And so, when we say light year, we are not just naming distance. We are naming the rhythm of reality. A year of light travel. A year of cosmic patience. A year of photons crossing darkness. If you are still here, still allowing your imagination to expand without resistance, continue with me a little farther. Let us continue outward, but this time with a different kind of awareness. We have spoken about distances as numbers, as scales, as comparisons. Now let us feel what those scales imply. When we say Proxima Centauri is 4.24 light years away, we are not just describing space. We are describing separation. Light leaving that small red star travels for more than 4 years before it reaches Earth. If a flare erupts on Proxima today, we will not know about it until years from now. That delay is built into the structure of the universe. The farther we look, the older the information becomes. This is why scaling distance gradually also means scaling time. The Earth-Moon distance of 384,000 kilometers produces a delay of about 1.3 seconds. Earth-Sun distance, 150 million kilometers, produces a delay of about 8 minutes. Voyager at 24 light hours produces a delay of 1 full day. Proxima at 4 light years produces a delay of more than 4 years. Each increase in scale stretches not only kilometers but awareness. Now imagine attempting communication across these distances. If humanity ever sent a message to a civilization orbiting Proxima Centauri, the message would take 4.24 years to arrive. If they responded instantly, their reply would take another 4.24 years to return. That means a single exchange of greetings would span more than 8 years. Conversations would unfold at geological speed. Decisions would require patience beyond anything we practice on Earth. Even within our own solar system, delays reshape control. Engineers guiding a spacecraft near Mars must account for several minutes of signal travel time. With Voyager, they wait nearly 2 days for a simple confirmation. The speed of light, though unimaginably fast, enforces a universal slowness at scale. This is the paradox. Light is swift beyond comprehension, yet cosmic distances are so immense that even light appears patient. Now let us return to the number 9.46 trillion kilometers. 1 light year. Instead of picturing zeros, picture time layered across space. 1 second, 300,000 kilometers. 1 minute, 18 million kilometers. 1 hour, more than 1 billion kilometers. 1 day, 26 billion kilometers. 1 year, 9.46 trillion. Each multiplication compounds gently, yet the final distance dwarfs intuition. This compounding is exponential in feeling, even if linear in calculation. And our brains resist exponential intuition. We underestimate large scales instinctively. We flatten curves that should rise sharply. That is a cognitive limit, not a failure. It simply means our ancestors did not need to visualize trillions to survive. The cosmos does not adjust for our comfort. It exists whether or not we can intuit it. Now imagine compressing our solar system for perspective. If the sun were the size of a small orange placed at the center of a city square, Earth would be a tiny grain of sand roughly 10 meters away. Jupiter would be a larger bead several dozen meters farther. Neptune would sit hundreds of meters out. On that same scale, Proxima Centauri would not be in the same city. It would be thousands of kilometers away, not across the street, not across the country, across continents. That emptiness between stars is real. It is not filled with bright points and swirling clouds at every step. It is overwhelmingly dark and sparse. That sparseness is why even traveling at the speed of our fastest probes leaves us essentially stationary compared to stellar separations. Voyager's 50 years of motion shrink to insignificance against 4 light years. And 4 light years shrink to insignificance against 100,000 light years, the width of the Milky Way. And that galaxy shrinks against millions of light years between galaxies. And those millions shrink against billions across cosmic expansion. The ladder of scale continues upward, each rung diminishing the previous one. This is not meant to make Earth feel small in a dismissive way. It is meant to clarify proportion. On human scales, 1,000 kilometers feels immense. On planetary scales, it is modest. On stellar scales, it is invisible. When astronomers use light years, they are aligning language with proportion. They are choosing a unit that scales naturally with the universe's architecture. 300,000 kilometers per second becomes the measuring stick. The year becomes the rhythm, and the result is a distance that carries built-in meaning. A light year is as far as causality can stretch in 12 months. That is the deeper realization. Distance is limited by time multiplied by light speed. Nothing can send information faster. Nothing can collapse that gap. So every light year represents a year of separation in knowledge. When you look at a star 10 light years away, you are seeing it as it was 10 years ago. When you look at a galaxy 1 million light years away, you are seeing it as it was 1 million years ago. Scaling distance becomes scaling history. The universe is not just wide. It is layered in memory, and we exist inside that layered archive, receiving photons that began their journey long before we were aware. If you are still here, still letting these expanding scales settle gently rather than resist them, continue with me just a little farther. Let us continue, and this time allow the scale to settle not as shock, but as quiet understanding. We have climbed from kilometers to light years, from seconds to centuries, from the moon to neighboring stars. Now pause and consider what happens when distance becomes so large that motion itself feels frozen. Imagine standing on Earth and looking toward Proxima Centauri, 4.24 light-years away. Light leaving Earth tonight will not reach that star until more than 4 years from now. By then, seasons will have changed many times. Children will have grown taller. Entire chapters of human life will have unfolded. And only then will that faint ripple of light arrive. That is the patience built into the structure of reality. Now stretch the imagination one more step. Suppose we could travel at 10% of light speed, which is about 30,000 kilometers per second. That is 100 times faster than Voyager. At that speed, reaching Proxima Centauri would still take more than 40 years. 40 years of continuous motion just to reach the nearest star. Even at a fifth of light speed, it would take over 20 years. These numbers are not technical barriers. They are physical consequences of distance. For light years means 4 years at light speed. Nothing can shortcut that without rewriting the laws that hold the universe together. And yet, within our galaxy, for light years is close. The average separation between neighboring stars in our region of the Milky Way is about 5 light years. That means if you drew a sphere around the Sun with a radius of 5 light years, you would include only a handful of stars. Space is not crowded like city streets. It is more like isolated houses separated by thousands of kilometers of empty desert. When we look at the night sky, the stars appear sprinkled densely across the darkness. But that is perspective. They only look close because they are projected onto a flat canvas of vision. In reality, each one sits at its own depth, separated by enormous light-year gaps. Now return briefly to the number 9.46 trillion kilometers. 1 light year. Instead of trying to visualize that distance directly, let us compare motion across it. If a car could drive at 100 kilometers per hour without stopping, it would take over 10 billion years to travel 1 light year. 10 billion years. That is nearly the age of the Earth. Even an airplane at 900 kilometers per hour would require more than 1 billion years. Even a spacecraft traveling at 17 kilometers per second, like Voyager, would need about 70,000 years to cover a single light year. And Proxima Centauri is more than 4 of those away. This is why scaling gradually matters. Without the stepping stones, moon, sun, light minute, light hour, light day, the mind rebels. But with each rung, the impossibility becomes structured. Earth to moon, 1.3 seconds for light. Earth to sun, 8 minutes. Voyager, 1 day. 1 light year, 1 year. Proxima, 4 years. The increments are steady. The consequences expand. Now imagine shrinking the entire solar system down so that the distance from Earth to the Sun is 1 meter. On that scale, 1 light year would stretch about 63 kilometers. Proxima Centauri would be more than 260 kilometers away. That means if the Sun were a lamp in your room and Earth orbited 1 meter from it, the nearest star would not be in the same building, not in the same neighborhood, not even in the same city. It would be in another city entirely. That emptiness between stars is not exaggerated. It is literal. This emptiness also explains why galaxies are structured the way they are. Gravity holds stars in orbit around the galactic center, but the distances between individual stars remain vast. Collisions between stars are extremely rare, even though hundreds of billions exist in the Milky Way. The separation enforced by light years keeps them apart like islands in a dark ocean. And beyond the galaxy, separation increases again. Millions of light years between galaxies. Tens of millions between clusters. Hundreds of millions between superclusters. The pattern repeats. Clusters of matter surrounded by enormous voids. The universe is not uniformly packed. It is filament, sparse, and stretched across scales that dwarf comprehension. Yet the same constant governs it all, 300,000 kilometers per second. That speed is not just a number. It is the conversion factor between space and time. Every light year is both distance and delay. Every additional light year adds another year to the story you are seeing. When astronomers say a galaxy is 1 billion light years away, they are also saying we see it 1 billion years in the past. Distance becomes memory. Scaling the impossible ultimately teaches humility, but not despair. The cosmos is vast beyond instinct, yet understandable through structure. Kilometer leads to 1,000 kilometers. 1,000 leads to million. Million leads to billion. Billion leads to trillion. Trillion leads to light year. Light year leads to galaxy. Galaxy leads to cosmic web. Each step follows logically, even if emotionally it feels overwhelming. And through it all, you remain here, on a planet orbiting a star 8 light minutes away, within a galaxy 100,000 light years wide, inside a universe billions of light years deep. The scale does not diminish your presence, contextualizes it. If you are still listening, still traveling outward through these widening circles of distance, type 1 in the comments. When you look up at the night sky, it feels immediate. The stars seem present, alive in this very moment, shining above you as if they belong to now. But they do not. Every point of light you see is a message traveling across time. Light does not arrive instantly. It moves at about 300,000 kilometers per second. That is unimaginably fast, fast enough to circle Earth more than 7 times in a single second. And yet, even at that speed, it still needs time to cross the distances between stars. This is the quiet revelation. To look into space is to look into the past. Take Sirius, the brightest star in the night sky. Sirius is about 8.6 light years away. That means the light entering your eyes tonight left Sirius 8.6 years ago. Nearly a decade has passed during its journey. If you are 20 years old, the Sirius you see tonight is the Sirius of your early teenage years. If you are 40, you are seeing it as it was when you were in your early 30s. The star feels present, but what you see is history. Now consider Vega, another bright star about 25 light years away. 25 light years means the light has traveled for 25 years before reaching you. If you are 25 years old, you are seeing Vega as it was the year you were born. When those photons began their journey, you did not yet exist. They have been crossing empty space for 1/4 of a century, uninterrupted, until they gently meet your retina tonight. And then there is Betelgeuse, the red supergiant in Orion, about 550 light-years away. The light from Betelgeuse that you see now began its journey around the late 1400s. While that light was just starting out, Leonardo da Vinci was alive. The printing press was new technology. Entire continents were unknown to much of the world. For more than 5 centuries, those photons traveled through the darkness between stars. Tonight they arrive. This changes how we understand the sky. The night is not a live broadcast. It is an archive. Even our own galaxy operates on these scales of time. The Milky Way is about 100,000 light-years across. That means if you could somehow travel at the speed of light, it would take 100,000 years to cross from one side to the other. Modern humans as a species are only about 300,000 years old. Crossing the galaxy at light speed would take 1/3 of our entire species' history. Our sun is located about 26,000 light-years from the center of the Milky Way. The light from the galactic center that reaches us tonight began its journey 26,000 years ago. At that time, humans were living as hunter-gatherers. Agriculture had not yet been invented. Cities did not exist. Written language did not exist. Everything we call civilization has unfolded while that light was traveling toward us. When we observe the center of our galaxy, we are seeing it as it was when human culture was still in its infancy. The present-day galactic center is unknowable to us in real time. We always see it as it used to be, and this is true everywhere. Light is not just illumination. It is information. It carries with it the story of where it has been. When you see a star, you are intercepting a stream of information that left long ago. You are decoding a message that has been traveling for years, decades, centuries. The farther you look, the further back you go. Telescopes deepen this effect. When astronomers observe distant galaxies billions of light-years away, they are seeing those galaxies as they were billions of years ago. The universe itself is about 13.8 billion years old. That number represents the time since the Big Bang, since space and time as we know them began expanding. Because light takes time to travel, when we look at galaxies 10 billion light-years away, we see them as they were 10 billion years ago. We are witnessing an earlier universe. Younger galaxies, younger stars. We are watching cosmic history unfold in reverse. The observable universe is about 93 billion light-years across. That number sounds strange, because the universe is 13.8 billion years old. How can something be 93 billion light-years wide? The answer lies in expansion. While light was traveling toward us for billions of years, space itself was stretching. Distances grew larger during the journey. So the most distant visible galaxies are now tens of billions of light-years away, even though their light has been traveling for 13.8 billion years. This means that every deep image of space is also a time machine. The further out we see, the closer we approach the beginning. There is a limit, though. We cannot see beyond the cosmic horizon, beyond the region from which light has had time to reach us since the universe began. There are places we will never see, not because we lack powerful telescopes, but because their light has not yet arrived, and perhaps never will. So tonight, as you imagine the stars above you, understand this gentle truth. You are surrounded by the past. Every photon is ancient. Every glimmer is a delayed arrival. The sky is not just space. It is memory. And you, standing here in the present moment, are the meeting point between past and now. In the next part of this journey, we will go even deeper into what this means, how time itself bends at high speeds, how relativity reshapes our understanding of past and present, and what would happen if you tried to travel across these light-year distances yourself. For now, just rest in this quiet realization. When you look up, you are not just seeing distance. You are seeing time. As we continue drifting through this idea, let the thought settle gently. Distance in space is inseparable from time. A light year is not only a measurement of how far something is, it is a measurement of how long ago it was. When we say Sirius is 8.6 light years away, we are also saying we see it 8.6 years in the past. When we say Vega is 25 light years away, we are saying we see it 25 years ago. And when we speak of Betelgeuse at about 550 light years, we are speaking of an image more than 5 centuries old. The farther outward your gaze travels, the deeper backward your vision reaches. This is not metaphor. It is physics. Light has a finite speed, and because of that, the universe reveals itself slowly. Imagine standing beneath Orion on a quiet night. Betelgeuse glows faintly red on the hunter's shoulder. That glow feels immediate, but in truth it began its journey around the late 15th century. Entire generations have lived and disappeared while that light was en route. Kingdoms rose and fell. Languages evolved. Scientific revolutions transformed our understanding of nature. Yet those photons moved steadily forward at 300,000 kilometers per second, unaffected by wars or discoveries, crossing interstellar emptiness until finally touching your eye. This makes every observation an encounter with history. Now widen the scale. Our galaxy, the Milky Way, stretches roughly 100,000 light-years across. If you could ride a beam of light from one spiral edge to the other, even at the fastest speed allowed by nature, you would need 100,000 years to complete the journey. 100,000 years ago, early humans were sharing the planet with other human species. The timeline of civilization occupies only a thin slice of that span. The Sun itself lies about 26,000 light-years from the galactic center. The light that reaches us from that central region tonight began traveling toward Earth 26,000 years ago. Back then, there were no cities, no agriculture, no written stories. Yet the core of our galaxy was already shining, and its light was already on its way here. When astronomers observe the galactic center, they are not seeing its present state. They are seeing it as it was during humanity's distant past. And this effect grows more dramatic as we look beyond our galaxy. Some galaxies visible through powerful telescopes are billions of light-years away. Their light began traveling toward us billions of years ago, when Earth itself was young or perhaps not yet fully formed. The universe is about 13.8 billion years old. That number represents the time since the Big Bang. Because light travels at a finite speed, The furthest objects we see are also the youngest versions of the universe we can observe. We are not just mapping space, we are mapping cosmic history layer by layer. There is a quiet elegance in this. The sky is not a single moment frozen overhead. It is a layered archive, each layer representing a different epoch. Nearby stars show us years-old light. More distant stars show centuries-old light. Distant galaxies reveal millions or billions of years of history. The observable universe, which spans about 93 billion light-years across today due to cosmic expansion, contains regions whose light has traveled for nearly the entire age of the cosmos. When we look to the most distant galaxies detectable, we see them as they were shortly after the universe began forming stars. We are witnessing early chapters of a story still unfolding. Now consider what this means for communication. If a civilization existed around a star 25 light-years away, any message they sent would take 25 years to reach us. If we replied immediately, our response would take another 25 years to arrive. A single exchange would require half a century. At 550 light-years, a message would take more than 5 centuries one way. Real-time conversation across such distances is impossible. Light speed is fast, but not infinite. This creates a universe where causality unfolds with delay. Events occur, and only years later do distant observers learn of them. In this sense, everyone in the cosmos lives slightly out of sync with everyone else. Even within our own solar system, delay exists. The sun is about 8 light minutes away. If it were to suddenly change, we would not know for 8 minutes. The moon is about 1.3 light seconds away. Every glance at it is a view slightly into the past. These are small delays, almost imperceptible. But as distances grow, delay becomes the defining feature of reality. And this leads us gently toward relativity. According to Einstein's insights, time itself is not absolute. It can stretch or contract depending on speed and gravity. While we are not yet traveling between stars at near-light speeds, experiments have confirmed that time slows for objects moving very fast. Atomic clocks flown on airplanes tick slightly differently from those on the ground. GPS satellites must account for tiny shifts in time caused by both speed and weaker gravity in orbit. Even here on Earth, time is not perfectly uniform everywhere. The universe is not synchronized in a simple way. The deeper we look, the more we realize that space and time form a single woven fabric. So when you look at the night sky, you are not just seeing distant lights. You are participating in a delicate intersection of space, time, motion, and history. You are receiving ancient photons, interpreting signals from long ago, standing at the edge of the present moment, while surrounded by echoes of the past. In the next part of our journey, we will imagine what it would feel like to travel close to the speed of light yourself, and how time would unfold differently for you compared to those who remain behind. For now, simply rest with this awareness. The universe does not reveal itself all at once. It reveals itself gradually, carried on beams of light that arrive softly, carrying stories across the darkness. Now let us imagine something even stranger. If looking far away means looking back in time, What would happen if you tried to travel across those light years yourself? What would time feel like then? Einstein showed us that time is not a fixed, universal ticking shared equally by everyone. Time stretches and compresses depending on motion and gravity. At everyday speeds, these effects are too small to notice. But as you approach the speed of light, time itself begins to change in measurable ways. This is called time dilation. The faster you move, the slower time passes for you compared to someone who remains at rest. This is not science fiction. It has been confirmed repeatedly in laboratories and in orbit. Atomic clocks flown on airplanes tick slightly slower than identical clocks left on the ground. GPS satellites orbiting about 20,200 kilometers above Earth experience time differently from clocks on the surface. Their onboard clocks gain about 38 microseconds per day due to the combined effects of their speed and weaker gravity. If we did not correct for this tiny difference, GPS navigation would drift by kilometers within hours. The system works only because we account for relativity. Now imagine scaling this effect up. Suppose a spacecraft could travel at 99.9% of the speed of light. Not quite light speed, but very close. If you boarded that craft and traveled to a star 10 light years away, from Earth's perspective the trip would take a little over 10 years each way, about 20 years total for a round trip. But because you are moving so fast, time for you would slow dramatically. While 20 years passed on Earth, you might experience less than a year aboard the ship. You would step off the spacecraft having aged only months, while friends and family on Earth had grown 2 decades older. You would have traveled not only across space, but into Earth's future. Push this even further. If you traveled at 99.99% of light speed to a star 100 light years away and returned, more than 200 years would pass on Earth. Entire generations would live and die. Languages would evolve. Nations might rise and fall. Yet you might experience only a handful of years during your journey. From your perspective, time aboard the ship feels normal. Your heartbeat, your thoughts, your sense of duration remain unchanged. But compared to the outside world, your clock runs slow. This is one of the profound consequences of light having a finite speed. Space and time adjust themselves to preserve that constant speed. Nothing with mass can reach light speed because doing so would require infinite energy. As an object accelerates closer to light speed, its energy requirements grow without limit. This creates a natural cosmic boundary. We can approach light speed, perhaps one day reaching fractions like 20% or 50%, but the final barrier remains unreachable. Light speed is not just a number. It is the structure of reality. And because it is finite, the universe unfolds with delay. Now return to the idea of seeing the past. When we observe galaxies billions of light years away, we are seeing them as they were billions of years ago. The observable universe spans about 93 billion light years across today because space itself has been expanding while light traveled. The universe began about 13.8 billion years ago, and light from the earliest observable epochs has been traveling toward us ever since. Some of the faintest galaxies detected by powerful telescopes appear as they were when the universe was only a few 100 million years old, still forming its first generations of stars. We are witnessing infancy on cosmic scales. In this sense, astronomy is archaeology. Telescopes are time machines. They do not transport us physically into the past, but they deliver ancient light to our present. Each photon carries a timestamp embedded in distance. When we look at the sun, we see it 8 minutes in the past. When we look at Sirius, we see nearly 9 years in the past. When we look at Vega, we see 25 years ago. When we look at Betelgeuse, we see more than 5 centuries ago. When we look at the center of our galaxy, we see 26,000 years ago. When we look at distant galaxies, we see millions or billions of years ago. The night sky becomes a layered record of time itself. And there is something deeply calming about this realization. The universe is not rushing. Events unfold, and light carries news of them patiently across vast darkness. Nothing is instantaneous at large scales. Everything arrives in its own time. Even the most dramatic events, like a supernova explosion, are seen only after their light completes the journey. Betelgeuse may one day explode as a supernova. It is expected to do so within the next 100,000 years. But it might already have exploded. If it did, and if that explosion occurred within the last 550 years, we would not yet know. We would continue to see the star shining peacefully until the light of the explosion finally reached us. The present state of distant objects is always hidden behind a curtain of travel time. So as you lie here imagining the stars, recognize that you are suspended between past and future. You see echoes of what has been. Meanwhile, your own light, reflected and radiated outward, is traveling into space. Somewhere, years from now, perhaps on a distant world, photons that once touched Earth will arrive. They will carry the faint imprint of this moment. In the final part of this journey, we will gather all these threads together and reflect on what it means that the universe is both vast and delayed, both distant and intimately connected by beams of light. For now, simply breathe and allow the idea to settle. Every glance upward is a quiet act of time travel, and every star is a messenger from long ago. As we come to the final stretch of this quiet journey, let everything widen one more time. We began with nearby stars like Sirius at 8.6 light-years and Vega at 25 light-years. We moved outward to Betelgeuse at about 550 light-years. We expanded to the Milky Way, roughly 100,000 light-years across, with our Sun sitting about 26,000 light-years from the galactic center. Then we reached outward still further to a universe 13.8 billion years old, and an observable cosmos now spanning about 93 billion light-years across because space itself has stretched while light was in motion. Each step outward has also been a step backward in time. The deeper the distance, the older the story. Now imagine the edge of what we can see. The most distant observable galaxies are so far away that their light has traveled for nearly the entire age of the universe. When that light began its journey, there were no stars like our Sun, no planets like Earth, no life as we know it. The first generations of stars were just igniting. Galaxies were still assembling from vast clouds of hydrogen and dark matter. That ancient light has crossed billions of years of expanding space to reach us now. We are not just looking across space, we are looking across epochs. There is a horizon beyond which we cannot see. Not because our telescopes are too weak, but because light from beyond that boundary has not had enough time to reach us since the beginning. The universe may extend far beyond what is observable, perhaps infinitely far, but we are enclosed within a sphere defined by light's travel time. In every direction, there is a limit set not by technology, but by age and expansion. This gives the cosmos a gentle structure. It is vast beyond imagination, yet finite in what can be known at any given moment. And within that structure, time dilation quietly operates as a reminder that even time is flexible. At extreme speeds, clocks tick differently. Near intense gravity, time flows more slowly. A clock placed closer to a massive object will tick more slowly than one farther away. These effects are tiny in everyday life but measurable. They reveal that time is not an absolute river flowing identically everywhere. Instead, it bends and stretches with motion and mass. The universe is not synchronized like a single mechanical clock. It is more like a vast fabric, gently warped by energy and movement. Light, traveling always at the same speed in vacuum, becomes the thread that stitches this fabric together. It is the one constant against which space and time adjust themselves. Because light speed is fixed, events unfold with delay, and simultaneity becomes relative. Two observers separated by great distances may disagree about when events occurred. What feels like now is local. Across light years, now dissolves into layered moments, each delayed by travel time. This has profound implications for communication across the stars. If a civilization exists around a star 100 light-years away, any message we send today would arrive a century from now. If they responded immediately, their reply would take another century to reach us. A single exchange would span 200 years. Conversations would stretch across generations. Decisions would require patience measured not in days or months, but in lifetimes. And yet, even with these delays, connection remains possible. Light still bridges the distance. It simply does so slowly. In this way, the universe feels both immense and intimate. Immense because distances are measured in thousands, millions, billions of light years. Intimate because every photon that reaches you has completed a precise journey through darkness to arrive exactly here, exactly now. You are at the intersection of countless beams of ancient light. Photons from the sun left 8 minutes ago. Photons from Sirius left nearly 9 years ago. Photons from Vega left 25 years ago. Photons from Betelgeuse left more than 5 centuries ago. Photons from the galactic center left 26,000 years ago. Photons from distant galaxies began their journey billions of years before Earth even formed. And yet, all of them converge in this present moment, entering your eye, triggering a tiny electrical signal in your brain, becoming awareness. There is something deeply peaceful in this perspective. The universe is not hurried. It unfolds on scales that make human anxiety feel small. Civilizations rise and fall while light travels between stars. Entire chapters of cosmic evolution pass silently while photons cross intergalactic space. And here you are, a conscious being made of atoms forged in ancient stellar cores, observing the cosmos that created you. The same physical laws that govern distant galaxies govern your heartbeat. The same space-time fabric that carries photons across billions of light years holds you gently to Earth. You are not separate from this story. You are part of it. Every time you look upward, you participate in a dialogue with the past. You receive messages that began long before you were born. And even now, light reflected from Earth is traveling outward, carrying faint evidence that this world exists. Somewhere, far in the future, that light will brush against distant dust or perhaps distant eyes. So tonight, as you rest beneath the idea of a sky filled with time, let it feel expansive rather than overwhelming. The universe is vast, yes, but it is also coherent, structured, connected by the steady, patient motion of light. Distance becomes history, observation becomes time travel, and the present moment becomes a meeting place between ancient photons and conscious thought. If you are still awake, still drifting gently through these billions of years and light years, quietly traveling through time with me, type 2 in the comments. And if you are still here, still floating gently in this awareness, let us allow the idea to soften even further. There is no need to hold all the numbers tightly now. 8.6 light years, 25 light years, 550 light years, 26,000 light years, 100,000 light years, 13.8 billion years, 93 billion light years. These are not numbers you are meant to carry like weight. They are markers, like distant buoys in an ocean, helping you sense the scale of the waters around you. What matters more than the precision is the feeling they leave behind. The feeling that the universe is patient. The feeling that light takes its time. The feeling that when you look up, you are participating in something far older and far larger than the present moment. Think again about what it means that the sun is 8 light minutes away. Every sunrise you have ever seen was already 8 minutes old when it reached you. Every warm ray on your skin began its journey while you were still in the recent past. Even the light that fills your room during the day carries a short but real delay. The world you perceive is always slightly behind the world as it is. This is true for nearby objects by fractions of a second, and for distant stars by years or centuries. Reality is never delivered instantly. It is always carried to you, and that realization can be strangely calming. There is space between events and awareness. There is travel time built into existence itself. Now imagine the galaxy slowly turning. The sun moves around the center of the Milky Way at roughly 230 kilometers per second. At that speed, it still takes about 225 to 250 million years to complete one orbit. A single galactic year is longer than the age of the dinosaurs. Since the last time the sun occupied this position in its orbit, entire species have risen and vanished. Continents have shifted. Mountains have grown and eroded. And all the while, light has continued its quiet work, crossing distances, connecting regions of space that would otherwise remain isolated in darkness. On the largest scales, the universe continues expanding. Galaxies drift apart as space itself stretches. Distant clusters recede. some so far away that their light will never reach us because expansion carries them beyond our cosmic horizon. There are parts of reality forever inaccessible, not hidden by walls or distance alone, but by the finite speed of light combined with the age of the cosmos. That boundary is not harsh. It is simply a feature of how things are. We live within a visible bubble defined by time. And within that bubble, there is still more than we could ever explore. 2 trillion galaxies may exist within the observable universe, each containing billions or trillions of stars. Around many of those stars, planets orbit quietly. Some of those planets may have skies of their own, with observers who look upward and wonder about distant lights. If such beings exist, they too see the past when they gaze into space. They too receive ancient photons. They too live inside a sphere defined by how long light has had to travel. The laws are universal. The experience, perhaps, is shared. There is a gentle symmetry in that thought. The same constant speed of light that limits communication also creates connection. Prevents instant contact, yet it ensures that information can travel at all. Without light, there would be no sight, no warmth from stars, no chemistry driven by radiation, no life as we know it. The very delay that separates us from distant galaxies is also the mechanism that allows us to know they exist. Light is both messenger and boundary, and you, here in this quiet moment, are part of that exchange. Your body is made of atoms forged in ancient stars that exploded billions of years ago. The carbon in your cells, the oxygen you breathe, the iron in your blood were all created in stellar furnaces long before Earth formed. In a very real sense, you are also a traveler from the past. The universe has been building you for billions of years. So when you think about light years, do not think only of separation. Think of continuity. Think of how everything is linked by shared origin and shared laws. The photons arriving tonight began elsewhere, long ago, but they end their journey in awareness. They become perception. They become thought. In that transformation, distance collapses into experience. Time compresses into a single quiet instant of seeing. And that may be the most remarkable part of all. The cosmos is unimaginably vast, yet it fits inside your mind as an idea. Billions of light years are held in a few calm reflections. That does not make the universe small. It makes consciousness extraordinary. So as you drift toward rest, let the scale remain wide but gentle. Let the stars be ancient without being distant in spirit. Let the past feel present, carried softly on beams of light. The universe does not rush, and neither do you need to. Everything arrives in its time. There is a limit written into the structure of reality. It is not a technical limitation, not an engineering challenge waiting for better materials or stronger engines. It is a boundary built into space and time themselves. That boundary is the speed of light. Light moves at about 300,000 kilometers per second. In a single second, it can circle Earth more than 7 times. In a year, it travels about 9.46 trillion kilometers. And yet, as astonishingly fast as that is, nothing with mass can go faster. This is not simply a rule we have not yet broken. It is a consequence of how the universe is constructed. More than a century ago, Albert Einstein showed that space and time are not separate things. They form a single fabric called space-time. When an object moves faster and faster through space, it must move more slowly through time. As its speed approaches the speed of light, time for that object stretches. Its clock ticks more slowly compared to someone at rest. At the same time, its inertia increases. It becomes harder and harder to accelerate. The closer you get to light speed, the more energy you must pour in for smaller and smaller gains in speed. If you could somehow push a spacecraft to 90% of light speed, time inside that craft would already be noticeably slower compared to Earth. At 99% of light speed, the effect becomes dramatic. To reach 100% of light speed, to match the speed of a photon, would require infinite energy. Not a lot of energy, infinite energy. And the universe does not provide infinite anything. So the barrier stands. Only massless particles, like photons themselves, travel at light speed. They do not accelerate up to it. They simply exist at that speed. From the moment a photon is emitted to the moment it is absorbed, it travels at light speed. For a photon, the journey across years of space happens without the passage of time in its own frame. But for us, bound to mass, bound to chemistry and biology, the speed of light remains an unreachable horizon. This cosmic speed limit reshapes everything about the future of humanity. It means that when we speak of a star 4 light years away, we are also speaking of a minimum 4-year travel time, even in the most optimistic imaginable scenario. It means that no message can arrive faster than light. No warning, no greeting, no rescue. Causality itself is protected by this limit. Cause must precede effect. Signals cannot leap ahead of time. And yet, within this boundary, imagination persists. One of the most ambitious concepts ever proposed for interstellar exploration is called Breakthrough Starshot. Announced in 2016, it suggests sending extremely small spacecraft to our nearest stellar neighbor, Proxima Centauri, which lies about 4.24 light-years away. Instead of building a massive starship, the idea is almost the opposite. Build something tiny, a probe weighing perhaps a gram. Attach it to an ultra-thin reflective sail. Then use powerful lasers from Earth to push that sail with concentrated light. Light carries momentum. When photons strike a reflective surface, they exert a small pressure. On everyday scales, this pressure is negligible. But if the sail is large and light enough and the laser beam powerful enough, that pressure could accelerate the tiny probe to perhaps 20% of the speed of light. 20% of light speed is about 60,000 kilometers per second. At that speed, the journey to Proxima Centauri would take roughly 20 years. Add a little more time for signals to travel back, and in principle, data from another star system could reach Earth within a few decades of launch. It sounds almost like science fiction, and yet the physics behind it is real. But the challenges are immense. The laser array would require power comparable to that produced by dozens of large power plants. The beam would need to remain precisely focused on a sail only meters wide as it accelerates rapidly away from Earth. The sail must survive enormous stresses. And once the probe reaches its destination, it cannot slow down. It would race through the Proxima system in a matter of hours, collecting as much data as it can before disappearing into interstellar darkness forever. Even in this most daring concept, the barrier remains. 20% of light speed is breathtakingly fast by human standards, but it is still only 1/5 of the ultimate limit. The journey still takes decades. Communication still takes years. The light year remains a real and unyielding measure of separation. And so we find ourselves in a quiet tension between possibility and boundary. The universe invites exploration, yet it sets rules. We can dream of sails pushed by starlight. We can imagine robotic messengers crossing the void. But we cannot outrun light itself. The cosmic speed limit stands like a shoreline. We may approach it. We may ride close to its edge, but we do not cross it. In the next part of our journey, we will explore what this limit means not only for travel, but for communication, for civilizations, and for the silence we hear when we listen to the stars. If light is the fastest possible messenger, then every conversation across the stars becomes a conversation with the past. Even within our own solar system, we already feel this delay. Signals to the moon take about 1 1/3 seconds each way. Signals to Mars can take anywhere from a few minutes to over 20 minutes depending on orbital positions. But once we step beyond the solar system, the scale changes from minutes to years. Proxima Centauri, our nearest stellar neighbor at roughly 4.24 light-years away, imposes an unavoidable reality. Any message sent today would arrive there more than 4 years from now. A reply, even if sent immediately, would not return for more than 4 additional years. One simple exchange of greetings becomes an 8-year loop. Conversation dissolves into correspondence measured in eras rather than moments. This is not a technological inconvenience. It is the geometry of spacetime itself. Imagine gently a future human settlement orbiting Proxima Centauri. Perhaps robotic explorers went first. Perhaps, over generations, humanity learned to build vessels capable of traveling at a fraction of light speed. Even if such a colony existed, it would not feel like an extension of Earth in the way that cities across oceans feel connected today. Political decisions made on Earth would arrive outdated. Cultural movements would drift independently. A child born on that distant world would grow to adulthood before receiving the reply to a question asked in early youth. Light speed enforces autonomy. Distance enforces divergence. The light year becomes not only a unit of space, but a unit of cultural separation. This delay has profound implications for the search for extraterrestrial intelligence. The universe is vast and ancient. Our galaxy alone, the Milky Way, contains hundreds of billions of stars. Many of those stars are older than our Sun. Many likely host planets. Some fraction of those planets may be rocky worlds within habitable zones where liquid water can exist. Statistically, it seems reasonable to suspect that life might have arisen elsewhere, perhaps even intelligent life. Yet when we turn our radio telescopes toward the sky, we hear silence. This puzzle is known as the Fermi paradox, named after physicist Enrico Fermi, who asked a simple question. If the universe is full of stars and planets, where is everybody? One possible answer is distance. Civilizations may exist, but the gulf between them may be so large that signals rarely overlap in time and space. Our own radio broadcasts have been leaking into space for just over a century. That means our electromagnetic bubble extends only about 100 light-years in radius. In a galaxy 100,000 light-years across, this is a tiny sphere, a thin ripple in a vast ocean. Even if another civilization lies 1,000 light-years away, our signals will not reach them for 900 more years. And if they responded immediately, we would not hear their reply for another 1,000 years after that. Communication windows may open and close without ever intersecting. Civilizations might rise and fall in cosmic isolation, separated not by hostility but by light years. There is also the question of travel. Even if a civilization mastered propulsion far beyond our current capabilities, the speed of light would remain the ceiling. To cross 10,000 light-years at 10% of light speed would still require 100,000 years. Interstellar empires, if they exist, would expand slowly, limited by causality itself. And so the silence may not indicate emptiness, but patience. The universe could be filled with life that simply cannot bridge the separations imposed by spacetime. Meanwhile, on the largest scales, another factor complicates the future: the expansion of the universe. Galaxies are not merely drifting apart through static space. Space itself is stretching. The farther away a galaxy lies, the faster it recedes from us due to this expansion. This relationship, described by Hubble's law, tells us that for roughly every megaparsec of distance, a galaxy's recession speed increases by about 70 kilometers per second. Over sufficiently vast distances, this recession becomes extraordinary. Some galaxies are receding from us faster than light, not because they are moving through space at forbidden speeds, but because the space between us and them is expanding. This does not violate relativity, since nothing locally outruns light. Instead, space-time itself grows, carrying galaxies with it. This leads to a remarkable and humbling consequence. There exists a cosmic horizon. Beyond a certain distance, light emitted today will never reach us. The expansion of space stretches the gap faster than light can close it. Regions beyond this horizon are permanently inaccessible, not just to spacecraft, but even to observation. They are part of the universe, but not part of our observable universe. As cosmic expansion accelerates, driven by what we call dark energy, more and more galaxies will eventually slip beyond our horizon. In the far future, distant galaxies will fade from view entirely. The night sky, for observers trillions of years from now, may contain only the remnants of our local group of galaxies, gravitationally bound together against expansion, surrounded by darkness. So the light year is not merely a number that measures distance. It is a measure of limitation, of delay, of horizon. It defines how far influence can travel. It defines which parts of the universe we can ever hope to see. It shapes the tempo of cosmic history. Within its boundaries, civilizations may bloom. Beyond them, regions of space recede into permanent silence. In the final part of this journey, we will reflect more deeply on what these boundaries mean for us personally, for our sense of meaning, and for the quiet connection that light still provides across the vastness. As we widen our view even further, the barrier of light becomes intertwined with the fate of the universe itself. The universe is about 13.8 billion years old. During that entire span, light has been traveling, carrying information outward in all directions. Yet, because space itself has been expanding during that time, the observable universe today is not 13.8 billion light-years in radius, but roughly 46 billion light-years. That means the most distant galaxies we can see emitted their light billions of years ago, and during the journey toward us, the fabric of space stretched, increasing the separation between us and them. The light finally arrives, but the galaxies themselves are now far beyond where they were when the photons began their voyage. This expansion is not slowing down. Observations show that it is accelerating. Whatever dark energy may ultimately be, it causes the large-scale structure of the universe to drift apart more rapidly over time. In practical terms, this means that more galaxies will eventually pass beyond our cosmic horizon. There are regions of the universe that are already receding so quickly that light emitted from them today will never reach us. No telescope, no matter how advanced, will ever observe those events. They are not hidden by dust or distance alone. They are hidden by time and expansion. If humanity survives for billions or trillions of years, the sky will not look the same as it does tonight. Distant galaxies will grow dimmer and rarer. Eventually, only our local gravitationally bound cluster of galaxies will remain visible, because gravity holds those galaxies together against expansion. Everything else will slip away beyond the horizon, leaving future astronomers with a much emptier sky. In that far era, it may even become difficult for observers to infer that the universe is expanding at all. The evidence will have faded into darkness. The light year in that distant future will still measure distance, but the accessible universe will be smaller in a practical sense, though vast beyond imagination. And yet, within these boundaries, something remarkable persists. Though we cannot outrun light, we are made of the same elements forged in stars whose light traveled for millions or billions of years. The atoms in your body were once inside ancient stars. Those stars lived, fused hydrogen into heavier elements, and then died, scattering enriched material into space. That material drifted through interstellar clouds, eventually forming new stars and planets, including Earth. In this sense, light years are not only measures of separation, but also of shared origin. The same cosmic processes unfold everywhere. When we contemplate the Fermi paradox again in this broader context, the silence feels less like emptiness and more like scale. The galaxy may host civilizations separated by hundreds or thousands of light years. Each civilization might look up at its own sky, wondering if it is alone. Their signals expand outward at light speed, forming spherical shells of radio waves. But those shells thin out as they grow. They weaken with distance. They take centuries or millennia to cross even modest portions of the galaxy. Civilizations might never overlap in time. One may flourish and vanish before its signals reach another. The speed of light enforces both possibility and isolation. Even if advanced beings developed propulsion at a significant fraction of light speed, colonization would be a slow process. A fleet traveling at 10% of light speed would take 40 years to reach Proxima Centauri, hundreds of years to cross even a small fraction of the galaxy. Over such timescales, cultures evolve. Languages change. Biological evolution continues. Interstellar societies, if they exist, would unfold like branching trees, each branch gradually becoming distinct. Light speed does not forbid expansion, but it ensures that expansion unfolds over epochs. There is a quiet comfort in this boundary. The universe is not chaotic in its rules. It is consistent. The same speed limit applies everywhere. The same equations describe motion in distant galaxies as on Earth. The barrier of light protects causality, prevents paradoxes where effects precede causes, creates a shared cosmic tempo. No matter where you are, no matter how advanced your technology becomes, you are bound to this rhythm. And within that rhythm, meaning still thrives. The fact that light takes years to cross between stars does not make the universe cold. It makes it patient. When you look at a star hundreds of light years away, you are receiving a message that began before modern civilization. When future beings look at our sun from a distance of hundreds of light years, they will see it as it was centuries ago. In this way, every star becomes a time capsule. The sky is filled not just with points of light, but with preserved moments, traveling steadily outward. So the light year is both wall and bridge. It is a wall because it sets a limit to travel and communication. It is a bridge because light still crosses it. Photons connect distant regions, carrying stories of nuclear fusion, of stellar births and deaths, of cosmic expansion. Even across billions of light years, connection persists through light itself. In the final message of this journey, we will gently gather these threads together and reflect on what it means, personally and collectively, to live within a universe where distance and time are intertwined, where the speed of light defines both our limits and our connections. And so we arrive at a quiet realization. The light year is not just a large number used by astronomers because kilometers became inconvenient. It is a statement about how reality is structured. It tells us that space and time are woven together, that distance cannot be separated from delay, that every separation in space is also a separation in when. When we say Proxima Centauri is 4.24 light years away, we are saying that even at the ultimate speed allowed by nature, it takes more than 4 years for influence to cross that gap. We are saying that the universe has a built-in tempo. That tempo shapes the future of humanity more than any specific rocket design ever could. We may build more efficient engines. We may harness fusion power. We may develop light sails or entirely new propulsion systems we have not yet imagined. We may send robotic probes to nearby stars within this century or the next. But unless the fundamental laws of physics change, the speed of light remains the boundary condition. It is not simple. This means that humanity's expansion, if it occurs, will be slow and generational. It will require patience measured in decades, centuries, perhaps millennia. Colonies, if ever established around other stars, will grow into distinct civilizations, shaped by local conditions and separated by years of communication delay. The galaxy will not become a tightly connected network of instant exchange. It will become a tapestry of distant lights, each evolving at its own pace, loosely linked by beams of information that take years to cross the dark. At the same time, the expansion of the universe reminds us that not all destinations remain forever reachable. On the largest scales, space itself stretches. Galaxies beyond our local group drift away faster and faster. There are regions of the cosmos we will never visit, never see, never influence. Even if humanity survives for billions of years and masters propulsion beyond anything we currently conceive, the accelerating expansion ensures that some horizons recede permanently. The observable universe is not the entire universe. It is simply the portion from which light has had time to arrive. Beyond that horizon lies more reality, but forever disconnected from us by cosmic expansion. This may sound isolating, and yet there is another way to see it. Within our horizon lies an almost unimaginable abundance. Hundreds of billions of galaxies, trillions upon trillions of stars, more planets than grains of sand on Earth's beaches. The fact that we cannot reach everything does not diminish what is accessible. It simply frames our perspective. A shoreline does not make the ocean smaller. It gives it shape. The speed of light gives the universe structure. And there is something profoundly grounding in knowing that the same rule applies everywhere. No civilization, no matter how advanced, outruns light. No signal leaps instantaneously across intergalactic space. Every cause flows forward into effect at a finite pace. The cosmos is not chaotic in its rules. It is consistent. That consistency allowed us to measure distant stars, to map galaxies, to calculate expansion, to understand that the universe is about 13.8 billion years old and roughly 93 billion light-years across in observable diameter. We are small within that scale, but we are not powerless. We are observers capable of understanding the boundary itself. When you step outside at night and look upward, you are not just seeing distant suns. You are witnessing the interplay between limit and connection. Each photon that reaches your eye has respected the cosmic speed limit. It has traveled faithfully for years, centuries, sometimes billions of years, carrying information across darkness. It did not cheat the barrier. It followed it. And because of that constancy, you can trust what you see. The sky becomes a record of journeys completed at light speed. The light year, then, is both a boundary and a bridge. It is the boundary because it tells us how far influence can travel in a given time, how slowly civilizations might converse, how patiently exploration must unfold. It is the bridge because light still crosses those distances. Even though nothing exceeds light speed, light itself connects the universe into a coherent whole. Stars illuminate one another across interstellar space. Galaxies exchange gravitational influence across millions of light years. The cosmic web remains a single unfolding system, stitched together by light and gravity. Perhaps this is the deeper perspective the light year offers. We live in a universe that is vast beyond intuition, yet governed by elegant limits. We are constrained yet connected. We cannot leap instantly to distant galaxies, yet we can understand them. We cannot outrun light, yet we can measure its speed with extraordinary precision. The boundary does not diminish wonder, it sharpens it. So tonight, as this quiet journey comes to rest, remember that a light year is not just a measure of distance. It is a measure of patience, of causality, of horizon. It defines how far the present can reach and how deeply the past can be seen. It reminds us that we are part of a universe where separation and connection coexist. If you have traveled all the way to the end of this calm cosmic reflection, gently type 3 and let that simple number mark the completion of tonight's quiet journey across the vast, luminous boundaries of the cosmos. And after you type that simple 3, let the number rest in your mind for a moment. 3 is small. 3 seconds pass quickly. 3 steps carry you only a short distance. And yet, in this journey, the number becomes a quiet marker of scale. We began with kilometers, with familiar measures. We moved through minutes of light, hours of light, years of light. We touched the idea that nothing with mass can outrun the universe's ultimate speed. And now we return gently to ourselves, because in the end, the barrier of light is not only about spacecraft and distant civilizations. It is about perspective. Every human life unfolds at a scale of decades. Civilizations unfold over centuries. Species evolve over millions of years. Galaxies rotate over hundreds of millions of years. The universe expands over billions. The speed of light weaves all of these timescales together into a coherent structure, prevents chaos. It ensures that influence spreads in an orderly way. It makes the cosmos understandable. If there were no speed limit, if information could travel instantly across any distance, the structure of cause and effect would unravel. Events could influence one another without delay. Paradoxes could emerge where outcomes precede origins. The universe might not hold together as a logical system. The light barrier protects coherence. It protects the arrow of time. It ensures that when you see a distant star, you are seeing a preserved past, not a contradiction. There is also humility in this limit. We often imagine progress as limitless acceleration, as breaking every boundary. But some boundaries are not obstacles to be shattered. They are contours that give shape to reality. The shoreline does not imprison the ocean. It defines it. The speed of light does not imprison civilization. It defines the rhythm at which civilization can extend. Within that rhythm, extraordinary things are still possible. Consider again the idea of a probe traveling at 20% of light speed. Even at that fraction, the journey to another star could occur within a human lifetime. Data could return across 4 light years in just over 4 years. Images of alien worlds, perhaps rocky planets orbiting a red dwarf, could appear on our screens. Not instantly, but eventually. There is a kind of beauty in waiting. The delay gives weight to the message. The light year gives significance to arrival. And if intelligent life exists elsewhere, they too live under the same constraint. They too would measure their neighbors in light years. They too would confront the silence between stars. Perhaps somewhere, Beings are looking at our sun as it was centuries ago, wondering whether anything or anyone orbits it. Perhaps their signals are already on the way, still traveling across the dark years from arrival. The barrier of light makes such meetings rare and slow, but not impossible. It turns contact into a long unfolding rather than a sudden collision. On the grandest scale, even as the universe expands and distant galaxies slip beyond our cosmic horizon, the local universe remains rich. Our galaxy and its neighbors are gravitationally bound. Over billions of years, the Milky Way and Andromeda will merge into a larger galaxy. Stars will continue to form. Planets will continue to orbit. Light will continue to travel year after year across interstellar space. The boundary does not end the story. It simply sets its pace. And within that pace, we exist as brief but aware participants. We are creatures who evolved under one ordinary star, who learned to measure its light, who discovered that the same speed applies everywhere. We turned that constant into a ruler, a clock, a bridge between time and distance. The light year is one of the most elegant human inventions, not because we created light, but because we understood it well enough to let it define our scale. So when you think of a light year now, perhaps it will feel different. Not just a daunting number of trillions of kilometers. Not just a technical term in astronomy textbooks, but a quiet reminder that the universe has limits and that those limits are consistent. That connection requires time. That influence travels patiently. That horizons exist, yet so do pathways. The night sky above you is not empty. It is structured by the speed of light. Every star you see honors that limit. Every galaxy beyond the reach of your eyes is still bound by it. And you, here on Earth, are part of that same lawful cosmos, bound by the same speed, connected by the same photons. Let that thought settle gently. The universe is vast. The distances are real. The boundaries are firm. And yet, across light years of space, light still travels. Connection still happens. And within that vast, luminous structure, you are here, small, finite, aware, listening quietly at the edge of the cosmic horizon.